Okay, we're on 9.5. We're looking at log functions. So when we have an exponential growth, it looks like that. B is greater than 1, so it's exponential growth. Looks like that. If I wanted the inverse of that, remember that would be a reflection over y equals x. So it would approach the y-axis instead of the x-axis. It would look like this. This is referred to as a logarithmic function. So that's exponential growth, and that's a logarithmic function. All right, so let's take a look. Logs are easy. It's just a different way of writing an exponent if you think about it. This is log base 4 of 16. So what's being asked here is 4 to what power gives you 16? So this is what's going on here. 4 to some power is equal to 16. Well, that's going to be squared, right? So if I take log base 4 of 16, that's just 2. The exponent is always the thing over by itself. So look, log base 8 on the next page of 1/8. Well, think about that. That would be 8 to what power would give you 1/8. 8 to what power ends up 1 over 8? Well, that would be a -1. Log base 3 of the square root of 3. Think about that. 3 to what power gives you the square root of 3? Well, remember, the square root of 3 could be written as 3 to the 1/2 power. So that's got to be 1/2. All right? So logs are just a fancy way of writing exponents. Just think of them as a fancy way of writing exponents. Okay? So now let's take a look at writing things that we know to be true into logarithmic functions or equations. So check it out here. 1, 2, 3. 5 to the 4th equals 625. 2 to the -3rd equals 1/8. And 3 is 4 to the 1/3 is equal to the 3rd root of 4. So how would I write that as a logarithmic? This would be log base 5 of 625 is equal to the power 4. It's powerful people are lonely. The exponent, the power, is always over here by itself. All right? So do you see how the components move? Let's do another one. Log base 2 of 1/8. So this is always the little base on the log. This is the number that it's trying to become. So what do I have to take 2 to what power gets me 1/8? And that would be to the -3rd power. Log base 4 of the 3rd root of 4 is 1/3. That's really, I could have written that instead of the 3rd root of 4 as 4 to the 1/3 power, and then it would have been a no-brainer. It would have just been 1/3. All right. How about the other way around? What if they give me logs and they want me to write them out and figure it out here? Log base 2 of 32 is what? And log base 4 of 2 is what? And log base 5 of 1/25 is what? So let's think about this. 2 to what power is 32? That would be to the 5th power. 4 to what power is equal to 2? Well, that would be the 1/2, or square root of 4 is 2. 5 to what power is 1 over 25? Well, think about it. It moved it down, so it's negative and squared, right? So -2. All right. All right, let's look at page 18. And 19 and 20. All right, so page 18 is solve the log equations. log base 6 of x is equal to 2. Solve for x. All right. So if we rewrite this, it would be 6 to that power is equal to that number. And so that's just 36. So basically we rewrote it outside of the log, and then it was easy. Let's take a look at 2. We got log base x of 81 is equal to 4. Well, what is that going to be? That's going to be x to the 4th power is equal to 81. Now, that might be a little tougher for a lot of us because a lot of people aren't thinking 4th power. What to the 4th power? It's actually 3. But if you didn't know that, we could have done it like this. We could have said, okay, look, I want to solve this equation. And so remember square roots? We did plus or minus the square root of both sides. Well, for logs, we would do the 4th root of both sides. And it would be, if this were the equation, it would be plus or minus 3. But logs can't have negative bases. So that's why we chucked the plus or minus part and just did the plus. So if you do the 4th root of 81, remember on your calculator, the trick there is take it to the 1/4 power. And that'll kick out a 3. All right. Number 3 is log of 3 of 1 is equal to x. So think about that. That's 3 to the x power is equal to 1. Well, anything to the 0 power is 1. So that's got to be x equals 0. No matter what that base is. That could have been base 38. And it would have still been x equals 0. So now they give us a few things. They said, look, anytime we have log base b of 1, that's equal to 0, no matter what the base. I just said that. If there's a 1 there and there's a log there, it's going to be 0. If I have log base b of b to the x, that's just x. Again, you're saying b to what power gives you b to the x power. Well, that's just x. And this one's weird. Log to the power log b of x is just x. That's just weird. But those ones are kind of obvious with what's going on. And then they ask a couple of questions about that. So let's take a look. We got log base 4 of 4 to the 6th. Well, that's got to be just 6 because I'm asking 4 to what power gives me 4 to the 6th. Well, that's 6. And then 7 log base 7 to the negative 3 power. That's the weird one where if you have the base and then the log base the same, then it's just that number, negative 3. All right. All right. Let's look at a couple of graphs. So look, if I have x is equal to 2 to the y, and so that's x and that's y, I'm going to actually pick y's and put them in and figure out what x is. So when y is 2, x is 4. When y is 1, x is 2. When y is 0, x is 1. When y is negative 1, x is 1/2. Y is negative 2, x is 1/4. And so when we look at that, that's that inverse graph that I alluded to on the first page. 1, 2, 3, 4. 1, 2, boom. 2, 1, boom. 1, 0, 1/2, negative 1, and 1/4, negative 2. So look, we have it approaching the y-axis. If you kind of tilt your head to the side, it's approaching the y-axis like a exponential decay. All right. And then number 2, that was number 1. Number 2, it's x is equal to 1/2 to the y power, and then what's x and what's y. And again, we're going to kind of do this in reverse. Normally, x is the independent variable and y is the dependent variable. But we're kind of flipping those roles. We're putting y in and figuring out x. So that's 1/4, 1/2, 1, 2, and 4. And when we graph that, take a look. We get, what do we get? 1/4 is up to 2. and 1/2 is at 1, and 1 is 0, and 2 is -1, and 3, 4 is -2. And so if you look at this, again, if you tip your head to the side, it's like exponential growth, but it's approaching the y-axis instead of the x-axis. And so it's kind of flip-flopped around. All right.